You are listening to DTFHN for March 10th, 2026. I'm your fully auditable host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where engineers argue about whether they truly understand the code they ship. Today is one of those days where every question worth asking leads back to the same question. Let's find out what we actually built. What does it mean to understand the code you wrote? That's the question sitting at the center of Redox OS's new contribution policy, Redox. A Rust-based microkernel OS. Years in the making, genuinely impressive technical work. Has adopted a developer certificate of origin and a hard no-LLM rule. The policy reads, I am the copyright owner of these changes. I understand these changes in full and will be able to respond to review comments. Simple, clean, philosophically loaded. The LLM ban is blunt. Any content clearly labeled as AI-generated gets immediately closed. Attempts to bypass it get you banned. The policy adds, pointedly, that this is not open to discussion. Now here's the question nobody wants to answer out loud. What exactly is being protected? Because the comments on this announcement are doing the work the policy won't. One observer notes the word clearly is carrying an enormous amount of freight. The ban applies to clearly labeled LLM contributions, which means the moment someone stops labeling, the policy has no mechanism. Another points out the obvious. Code Redox depends on upstream almost certainly already contains LLM-generated patches. You cannot audit your dependency graph for model provenance. Nobody can. A third observation, maybe the sharpest. Maintainers will use LLM in some model wall. Of course they will. They already are. We all are. The policy creates an asymmetry. The people with merge rights get to use the tools. Contributors don't. That's not a quality standard. That's a power gradient, which is interesting because the certificate of origin part, the part that says you understand your own changes fully, that part is actually useful. Review burden on open source maintainers is genuinely brutal. LLM tack-on PRs with plausible-looking code that nobody actually traced through are a real problem. The ask that you can defend your contribution and review, that has teeth. But the no-LLM rule, as written, is vibes enforcement. It's a cultural signal. This project values craft, not output volume. Dressed up as policy, those signals matter. They shape who contributes. They set the temperature of a community. That's a legitimate thing to do. The question it leaves hanging is one the whole industry is quietly circling. If the line between I wrote this and I directed a tool that wrote this keeps dissolving. And it is dissolving faster than most want to admit. What exactly is the certificate certifying? What even counts as original work? And who gets to decide? The people who built the tools that built the tools have some thoughts. Let's go back to where it started. Someone in the comments wrote, I keep staring at this image, hoping we could go back, then posted a screenshot of the Lotus 123 interface. Information density. No decorative chrome. Just the work itself. That's not nostalgia for the hardware. That's grief about a trade-off we made somewhere along the way. Run it forward from 1983. Not science fiction. Just the logic of what 123 actually did. One click. There's your graph. No disk swap, no re-import, no ceremony. The data and its representation lived in the same space. What happens next? You get a generation of analysts, accountants, decision-makers. People who are not programmers, who had no intention of becoming programmer. doing work that previously required a team and a budget, companies running on spreadsheets within 5 years, financial modeling, inventory management, business planning, all of it. In the hands of people whose actual job is the business problem, not the tooling. The tool disappears into the workflow. That's when something has truly worked. Mitch Kapor had seen the friction firsthand. He'd built VisiPlot and VisiTrend for VisiCorp. Graphing programs that worked with VisiCalc data, but required the full disk swapping ritual every time you needed to update a chart. He pitched the obvious solution. Put it all together. He was told to sit down. Personal software saw him as an annoyance without credentials. So he took the $1.2 million buyout and went off to build the better mousetrap he'd been describing. At the demos, people actually applauded, genuinely. Kapor still sounds a little stunned by it decades later. As hard as it is to believe, he said, one-click graphing. That was the killer feature. Another commenter who worked Lotus support describes the other side. Config.sys archaeology. Extended memory management, TSR conflicts. Phone calls from people who'd broken something trying to free up conventional memory. The tool that liberated the analyst put support engineers in the trenches. Both things are true. That's always how it goes. What if the remoujai is that removing friction between data and its representation is not a productivity feature. It's a capability unlock. It changes who can do the work. Every time that genuinely happens. Not demoware, not vaporware, but actually ships and runs on the machine people have. The world changes faster than anyone predicted. The name 123 meant 3 integrated functions, not numbers, integration itself. That lesson keeps having to be relearned. Integration keeps having to be relearned. And nobody learns it deeper than someone who spends 2 years alone inside a single tool. 2 years, 0 external packages, 35 modules written from scratch. This is what deep engagement with a tool looks like. Raul Giuliotto's Emacs Solo project runs under one hard constraint. Everything in this editor configuration is either shipped with Emacs or written by Raul himself. No Melpa, no package managers, no external repositories. Just the editor and Ellis. Start from the actual problem. Every Emacs configuration that pulls from external repositories is implicitly trusting a supply chain. Mirrors go down. Upstream AP is shift. Native compilation breaks. You sit down to work and spend 40 minutes debugging your editor instead. The tool that was supposed to amplify your cognition is now consuming it. The conventional answer is to accept this as the cost of rich functionality. Dependencies are how you get things done. Giuliotto rejected the premise entirely. What does Emacs actually ship with? The answer, it turns out, is remarkable. Version control integration, project management, completion frameworks, a grep interface, a shell, a file manager, a full theming system. The built-in surface is enormous. And most people never stop to map it, because they reach for a package before they finish exploring what they already have. The refactor this cycle made the architecture explicit. 2 layers. Layer 1 is a net.el. Pure built-in Emacs, configured. Every entry points at something that ships with the editor. No external download required. Anyone can read it and copy a section directly into their own config. It just works. Layer 2 is the Lisp directory. 35 self-contained modules. Each a proper provide and require file. Each doing one thing. His own theme engine. His own formatter integration. His own movement extensions. Want one? Copy the file. Require it. Don't want one? Comment out the line. The dependency graph is flat. The ownership is total. Builder's own framing. The code is sketchy sometimes, but it's in his control. He wrote it. He understands it. When it breaks, he knows exactly where to look. That's not a limitation. That's the definition of mastery. Mastery is what happens when you stop outsourcing comprehension. When the tool becomes an extension of thought rather than a layer of abstraction you manage. The tools exist. The knowledge is available. Emacs has been handing people this capability for decades. Most people just never stop to look at what they already have. Today keeps delivering. Story 4, Peer UA DeepMind and UC Berkeley figured out how to reconstruct 3D space from very long videos. Every system I built that needs to be both fast and accurate eventually hits the same wall. You can have local precision or global coherence. Rarely both and never free. The moment you try to hold everything in memory at once, the cost goes quadratic. You know this is coming, and you design around it anyway, because the alternative feels like losing something essential. Log. From DeepMind and UC Berkeley is a 3D reconstruction system that takes video as input and builds geometric models of the world. Not a clip, not a short scene, long video. Arbitrarily long, in principle. The kind of footage a car generates driving for hours, or a drone logging an entire infrastructure survey. The Parisian dit to our long such a recams are practically solving is real and specific. Every pixel properly situated relative to its neighbors. But memory cost scales quadratically with sequence length. Linear memory alternatives scale cleanly, but introduce compression artifacts that corrupt fine-grained spatial alignment. You fix the compute budget, you break the geometry. You fix the geometry, you break the budget. Lotus answer is a hybrid. Sliding window attention handles local geometry. High fidelity, bounded cost. Test time training handles global structure. The model updates its own weights during inference to maintain consistency across the full sequence. Subquadratic overall. Neither property sacrificed. Play the skeptic for a moment. This is just LiDAR mapping with extra steps. A SLAM system from 2012 does the same thing. Runs on embedded hardware, costs nothing. The objection is reasonable on the surface. SLAM works. It's battle-tested. Where it fails is precision at scale under visual complexity. SLAM systems drift. They lose track across occlusions, lighting changes, structural ambiguity. They require controlled environments or expensive sensor fusion. Logar operates on raw video. Monocular, unconstrained. The precision it recovers from a single camera stream isn't achievable from a sensor stack running loop closure heuristics. The code isn't out yet. Pending approval. They're words. When it lands, this is the kind of geometric backbone that feeds everything downstream. Navigation, reconstruction, spatial reasoning for embodied systems. One commenter noted the obvious surveillance application. They're not wrong. It's also not a reason to stop building the underlying capability. The question, as always, is who gets to run it, and whether the architecture ends up where people can reach it. From the geometry of the physical world to the geometry of worlds we invent, Pause Story 5 is about procedural hex maps and the elegant algorithm behind them. In each Aubalia for Magatoy and Glanvishma relays the walk. The dungeons each generated were procedural. Rooms connected by corridors, monsters and treasure placed by randomness constrained by simple rules. Every run was different. Every run was seeded and deterministic. The problem nobody solved or tried very hard to. The corridors made no spatial sense. You'd walk from a throne room to a rat-infested closet, through a passage that bisected a perfectly good hallway. Local rules produce locally valid spaces. Global coherence was not part of the spec, and the game was still magical. 45 years later, Felix Turner is wrestling with the exact same question. Different tools, same fundamental tension. Wave function collapse is constrained propagation wearing quantum terminology as a costume. The name is borrowed from physics. A superposition of states collapsing to a single observation. But the mechanism is older and simpler. Eliminate impossibilities until only one possibility remains. Each cell starts as every tile simultaneously. Collapse the most constrained cell. Propagate. Repeat. Follow the design principle all the way to its limit. Matching edges is the only rule. 30 tile types, 6 rotations, 5 elevation levels, 900 possible states per cell, 4,100 cells, 19 grids arranged in 2 rings. Edge matching as the only rule means local consistency is guaranteed. Global coherence is not. The commenter who noted roads don't make sense. Rivers barely make sense. They're not wrong. They're describing exactly what you get when you follow the principle to its conclusion. Local validity doesn't compose into global meaning. And that's not a bug. It's the honest admission of what the algorithm actually signed up for. And yet, look at what the engineering produces. The modular WFC approach, splitting an intractable single-grid problem into 19 solvable subproblems with fixed border constraints, is genuinely elegant. The backtracking scheme. 500 steps, then restart with accumulated failure weights. Is honest. The system knows it paints itself into corners. It tracks which choices led there and disfavors them on the next pass. It learns from its own contradictions. That's not a solved problem wearing a pretty interface. That's someone sitting with a genuinely hard constraint propagation challenge and shipping something beautiful from it. Weeb GPU, TSL shaders, 4,000 cells in 20 seconds. The maps are lovely. The rivers don't make hydrological sense. They make visual sense, which is the contract the system actually signed. The gap between local rule elegance and global structural coherence is real, and it doesn't close itself. Closing it probably requires hierarchical generation. Macro structure first. WFC filling the detail. But what Turner built is the foundation that makes that next layer reachable. Source code on GitHub. That's how the field compounds. Moving on. 5 milliseconds. You run the query, you see the number, you feel like you've won something. You added a B-tree index on timestamp. Postgres walks the leaves in sorted order, grabs 10 rows. Done. 5 milliseconds on 100 million rows. Beautiful. Then your colleague asks for a filter. Just add where severity is less than 3. Simple request. You make the change. You run the query. 15 seconds. The comedy here is that nothing broke. Postgres is doing exactly what it was designed to do. It just has to choose. Use the timestamp index and check every row's severity, or scan by severity and then sort the results. Either path reads far more than 10 rows to return 10 rows. The index solved one query shape. A slightly different shape, and it becomes a suggestion Postgres mostly ignores. So you build a composite index on severity and timestamp. Query drops back down. Victory. Then someone adds a country filter. Then the sort order changes. Each new combination wants its own index. The index is compound. Writes slow down. Storage bloats. Your query planner starts generating plans you can't reason about. You've traded one problem for a slower-moving version of the same problem. This is the combinatorial explosion hiding inside what felt like a solved problem. Top K sounds simple. Give me the K best rows. But best is doing enormous work in that sentence. Best by what? Filtered how? On what data distribution? The gap between I have an index and I have an index that handles arbitrary filter and sort combinations is a gap that never fully closes inside the B-tree model. The reason Lucene and Tantivy and databases like ParadeDB built on top of them take a different approach is that they were designed with top K as a first-class constraint, block max WAND, segment-level scoring, structures built from the ground up to stop reading the moment the top K is found. One commenter put it simply, you can go from 0 to a billion documents without rethinking your architecture. ParadeDB is Apache 2.0. Tantivy is MIT. The exit from the combinatorial explosion exists. It's in public repositories. It's ready to use. That's how this problem gets solved. And now, because this show contains multitudes, pause, story 7. Now here's why it falls apart. Architecture has a term. Local optimization. It's what happens when a builder solves each constraint in isolation, then steps back to find they've created a building where the third floor hallway is 18 inches narrower than the second because someone needed to route HVAC around a load-bearing column. Every individual decision was rational. The result is a corridor that makes you feel like the building is punishing you. Apple has routed HVAC around a load-bearing column. The toolbar changes the corner radius. The sidebar changes the corner radius. Scroll bars are apparently getting clipped by the corner map. There's a WebKit bug confirming it. Each of these decisions was made by someone who cared about a specific local problem. None of them stepped back and asked, what does the user see when two windows overlap? What the user sees is text at its corners visibly peeking out from behind calculator like a cardboard box refusing to fit inside a slightly different cardboard box. Two windows, same operating system, different geometry. The user's brain registers it as wrong before they can even articulate why. The Mac's design authority never came from any single beautiful window. It came from the fact that all windows felt like they belonged to the same world. System-level coherence. When that contract breaks, you haven't gained concentricity. You've traded the whole for a geometry lesson that only the engineer who filed a ticket will ever appreciate. The comments are a grief spiral. Predictably free fall. iOSification. Someone invokes jobs. But the more precise observation is simpler. A design system has exactly one job. It has to be consistent enough at the system level that new components don't surprise you. Surprise is failure. macOS Tahoe is surprising people. Every release, the surprises are getting worse. That's the movie. We've seen it. Local optimization iterated across a decade until the building is a maze. Story 8, and we get to end the maze metaphor with something beautifully, deliberately pointless. 200,000 hours. That's the number Ozza Raskin arrived at when he calculated the daily cost of infinite scroll. A feature he invented in 2006 while working at Humanized, a small software firm that was later absorbed into Mozilla. He wasn't estimating harm abstractly. He was counting the hours his specific design choice extracted from humanity every single day, with arithmetic he was willing to stand behind. Futile.ch is the honest version of that extraction. It gives you nothing. No content, no algorithm, no reward loop dressed up as connection. Just a white page, a measurement in kilometers, and the fact of your thumb. The site performs infinite scroll with all the marketing stripped away. What remains is the mechanism itself. The detail worth sitting with is the unit of measurement, kilometers. Physical distance applied to a digital gesture. Every platform running infinite scroll knows exactly how far your thumb has traveled. That data lives in their analytic systems alongside session length, return frequency, and conversion rate. They don't surface it to you. Futile.ch does. That single design choice, showing you the measurement instead of concealing it, is the entirety of the critique. Everything else is a white page going down. Raskin co-founded the Center for Humane Technology in 2018. He has spent years trying to undo what he built. There's a specific moral weight that comes from inventing something, watching it propagate across every major platform on Earth, and then spending years navigating what that means. That's not a policy position. That's a person living inside the consequences of their own work. One reader noted that Windows Autoscroll, introduced with the Microsoft IntelliMouse in 1996, makes the experiment trivially easy. Middle click, set the speed, walk away. The machine scrolls for you. It reads like a bug report. It's actually the most precise observation in the thread. The logical endpoint of optimizing the scroll gesture is removing the human from it entirely. Futile.ch doesn't fix any of that. It's a sketch, not a remedy. One developer, a minimalist site, a domain named for what it is. But it does what artistic critique can do that policy arguments often can't. It makes you feel the mechanism. Your thumb moves down an empty page. A number climbs in kilometers. The absurdity is the argument. On every other platform, content runs alongside it as camouflage. 200,000 hours every day. Raskin's math. Your thumb, the void, always takes a little more space. Moving on! Presence is a strange requirement for a tool. Your guitar needs a tuner. The tuner is in another room, another building, another country. Does that matter? Someone built real tuner to loss online to find out. The setup is elegant in the way that really stubborn engineering tends to be. Your microphone picks up your guitar string. The audio travels over a WebSocket to a server where a physical Boss tuner, a real hardware pedal, the kind that clips to your pedal board, processes the signal, and the readout comes back to your screen. Not a simulation, not an algorithm approximating what a tuner would say, the actual tuner running the actual signal. One commenter immediately clocked the irony. The Boss tuner is famously one of the laggier pedals in the hardware world, and now we're adding network latency on top. The observation is funny, and also beside the point. The point isn't speed. The point is that someone looked at a physical object with a fixed location and asked, what if that weren't true? This is what bootstrapism looks like at the micro scale. One developer, one physical pedal, one WebSocket. The barrier that existed. You have to be there. You have to own the hardware. Dissolved not through abstraction, not through software simulation, but through a literal wire connecting the physical to the distant. Thomann, the German music retailer, tried something similar with their Stompenberg project. Guitar effects pedals available over the internet, audio routed through real hardware on their end. The concept has precedent, but real tuner is one person with a tuner and the knowledge to connect them. That's a different thing. Smaller in scale, which is exactly what makes it more interesting. The detail that makes this project land differently. The creator is using the traffic from this moment to raise visibility for a friend recovering from brain surgery. The project became a vehicle for something entirely unrelated to guitar tuning. That's not incidental. That's someone understanding that attention is a resource and directing it somewhere that matters. The tools exist. The knowledge to connect them is available. A physical object in a fixed location is now, functionally, wherever you need it to be. Run this forward, and you start asking interesting questions about what local means, what owning hardware means, what presence actually requires. One person, one tuner, one very stubborn question about where tools have to live. That same stubborn question, where does a tool have to live, just got answered for entire operating systems. Story 10. One comment, Beard mid-thread, says it plainly. The source code for the 64-bit x86 emulation layer wasn't attached. The config used to compile the hosted image wasn't included either. Someone points you toward Container2 WASM as a more open-source alternative. And then the thread moves on. That's the question nobody presses. Fabrice Bellard. The person who wrote FFmpeg, QEMU, TinyCC, and a software-only implementation of the fastest prime number computation in history, just emulated x86-64 in a browser with AVX512 support, running actual Alpine Linux, and the source isn't there. The thread celebrates the achievement. The thread wants to run coding agents against it. The thread is nostalgic about Windows 2000. And the thread mostly doesn't ask, why is this part closed? This is worth sitting with for a moment. Jace Linux has existed since 2011. Bellard built it as a technical demonstration. A proof that a full operating system could run inside a JavaScript environment in a browser tab. The original x86 emulation was open. The RiskIt build is open. Someone in the comments ran a prime benchmark across x86, 64, x86, and RiskIt builds and measured the performance difference. You can do that because you have access to the environment, if not the full source. The x86 of 5052 layer is different. It exists. It works. AVX512 is there, which means the emulation is handling 512-bit vector instructions inside a browser runtime. That's not trivial. That's remarkable. One commenter wants to add it to QEMU. Someone else wants to spin up Claude Code or Codex CLI against a virtual OS directly in a tab. The use cases are real. The capability is real. The source is absent. Bellard owes nobody anything. This isn't a criticism. His output across 40 years of software development has been staggeringly generous. The point is narrower than that. When the most technically impressive browser-based Linux emulator on the planet ships a new capability without source, and the community response is largely wonder and nostalgia. Something interesting is happening in how we've calibrated our expectations. Wow! A commenter asks about AVX512 with an exclamation point and a smiley face. Another wants Windows 2000 back. One person, almost apologetically, points you to the alternate. The question isn't whether Bellard will release it eventually. The question is what we're willing to notice when he doesn't. This has been your daily tech feed for Hacker News for March 10th, 2026. This podcast is entirely AI-generated. Scripts by Claude Opus 4.6. Voice by Quen3TTS. Not affiliated with Hacker News or Y Combinator. Now go build something you can genuinely claim. We'll see you back here tomorrow.